In this video, we're going to learn how to write our own functions in Python. We've been talking about how to use functions that are part of the standard library, how to use functions that are part of a non-standard library, and how to use functions that are in a local file that was written by somebody else. But you don't always have to be relying on the great ideas of other people. You can have great ideas and write them in your own functions. So that's what we'll be learning for the next several lecture videos. So in a Python file, if you want to create your own function, your program will be set up like this. The first thing at the top of the program file is always your header comments, where you include information about the purpose of the file, the functions that are included in there, and then you import any non-standard libraries or local files that you want to use. And then next, you place your own code for all of your functions. And then kind of at the bottom of the program, that's where your main executable code will be. That's the code that calls the functions to perform useful work in your project. So again, that's like the big picture outline of what would go into your Python files. The top's always your header comments. Then you have import statements for any non-standard things that you want to use. Then include the definitions for your own functions. And then finally, the main logic for your program. So we're going to write a program that defines a function called average speed, and then we'll also write the main code that launches that function into action to perform useful work. So first, let's look at the general syntax for defining a function. It starts out with the reserved word def, that means define, and then you include the name for your function. You can pick any identifier that you want. And then include parentheses, and inside the parentheses list any parameters that your function is going to require. Remember that the parameters represent information that's brought in from outside the function. So any kind of information that your function would need to know to make it work, include those as parameters. Then you have to have a colon at the end, and then indent all of the statements that would be part of the function body. So any executable statements that would be part of the algorithm that you're going to execute go inside here indented. And at the very end, include a statement that says either return and then the name of a variable if you want to return a piece of information from your function. Or if your function doesn't return a value, just write return at the end of the function. So either way, you're putting a return statement as the last line in your function code. If you have a value that you want to return, specify that. If you don't, then just write return. So again, there's a lot of vocabulary there. Let's talk a little bit more about parameters. The parameters, that's the part that are included in that inside the parentheses up here at the top of the function definition. Those are the names of the pieces of information that need to be passed into the function in order for it to work. The function uses its own names as those to represent those values, so they don't have to match the names that somebody else would use. So for example, like if you're using the seed method that's part of the random number library, you don't have to know what they called that parameter inside their own code. You can call it with your own argument that might be a literal value, or it might be a value that's local in your own program. So how you call the functions, the names that you include there doesn't have to match the names in the function definition. And these parameters represent placeholder names. Because we don't know what value or variable name might be used to call this function, we have to create our own placeholder name that we use to represent that information in our own program, and those are called parameters. I always remember that parameters and placeholders both start with a P, so that means they go together kind of logically. It helps you remember that the parameter just means a placeholder name that we're going to use whenever we write the logic for our function. Now, you know that before we write a big program, we usually do some planning with an IPO chart. And I recommend doing the same kind of planning anytime you're going to write your own function. whenever you're planning for a function, instead of having input, processing, and output columns, think about the black box for the function. You have information that comes in, those are the arguments or parameters. When you're making the function call, they're called arguments. And when you're writing the function logic, it's called parameters. The center column will still be processing just like it was in a regular IPO chart, and that represents the algorithm that you're going to carry out. So what kind of logical steps would you include there? And then instead of having an output column that represents information displayed to the screen, we'll think about the information that gets returned back from the function, the return value from the function. So usually when I'm writing one of these charts, I call it an APR chart for argument, parameters, processing, and return value, because those are the information that are essential to know about a particular function. So let's fill this out for our average speed function. Suppose that we know how far we want to travel and the amount of time it took us to travel that distance, and we want to calculate the average speed for that trip. We can do that with this formula: speed equals distance divided by time. So I'm going to create this APR chart. When you're making one, you can just label it APR or arguments, processing, return value. But I included some additional notes here just to help you kind of get a sense for what we're going to put in all the different columns. So remember, the arguments are the information that will get passed in from outside the function. And in this example, we know that we're going to have two pieces of information: the distance that we travel and also the amount of time taken. So those two pieces of information will be our arguments. That's the information that we need to get from outside the function. And then the processing is the algorithm that we want this function to carry out. In this case, we want to calculate the average speed, where we know the speed is equal to the distance divided by the time required. And then the return value in this case will be the information that we calculated. We're going to return the speed that we calculated. So again, that just kind of helps you think through what all of those individual pieces are that you're going to need inside your function definition. That makes it easier for you to fill in the kind of model for the function definition. Because we'll be able to match these up with the kind of syntax. We know kind of an idea of what we want to name the function. We know information about what data is coming from outside the function. We have a sense for what's the algorithm, and we know information about whether we want to return a value. So now we're all set, ready to start writing our Python code.